Under the surface of America's greatest city lies something ancient and powerful. A massive, hidden mass of molten rock, nearly the size of the state of Maine, is inching its way toward New York. It's called the Northern Appalachian Anomaly. Scientists call it a hot blob, a living, oozing presence in Earth's mantle. What exactly is it? How dangerous is it? And could it ever threaten the millions above? Stick with me. These are questions even the greatest minds on Earth are only now beginning to answer. The Northern Appalachian Anomaly, NAA, is a vast thermal upwelling, a region of abnormally hot, sluggish rock, located some 125 miles beneath Earth's surface, stretching an astonishing 220 miles across New England. Newsweek. Live Science. Until recently, geologists believed it was a remnant from when North America broke away from Africa around 180 million years ago. That theory crumbled under new evidence. A recent study published in Geology reveals a more recent origin, about 80 million years ago, when Greenland and North America split apart. Live Science. New York Post. Newsweek. This blob is not static. It drifts and migrates, traveling southwestward at approximately 12 miles per million years. According to seismic tomography, this movement is linked to deep Earth processes described as mantle waves, chain reactions of rock convection triggered by tectonic rifting. To locate and map the NAA, researchers used seismic tomography, a technique that works like an MRI for Earth. By tracking the speed at which seismic waves travel through the mantle, scientists detected a zone where waves slowed, indicating hotter, less dense rock. University of Southampton's Professor Tom Jernon, lead author of the study, described the anomaly as a result of a geological instability, essentially a Rayleigh-Taylor drip, where denser rock sinks, pushing heat upward like a plumes of molten wax through water. Computer simulations and plate tectonic models demonstrated how this blob formed near the rift zone and began migrating inland, carrying its heat footprint beneath the continent. Crucially, this discovery challenges long-held assumptions that the eastern United States is geologically dormant. Instead, the NAA reveals dynamic processes just steps below the surface. Though hidden for millions of years, the NAA has likely shaped surface geology, especially the fate of the Appalachian Mountains. Despite relentless erosion, these ancient ranges remain elevated, an anomaly in Earth's natural wear and tear. Jernon likened the mechanism to a lava lamp or hot air balloon. Heat at the base of a continent can remove part of its dense root, making the crust more buoyant and causing uplift. Secret NYC. New York Post. Once the blob drifts past, the land above may begin to sink, and erosion will slow the mountain's survival. New York Post. This same process, known as mantle waves, may have recurred across the region, with this blob being just one in a chain of subterranean movements. Understanding this gives geologists a powerful tool to explain ancient volcanic activity, mountain formation, and the behavior of Earth in regions once thought inactive. Phys.org. Is New York City in immediate danger? No. This molten mass moves at roughly 12 miles every million years. At that pace, it would take 10 to 15 million years to get directly underneath. Still, the knowledge that something warm, quasi-molten, and powerful lurks beneath a geologically stable region is chilling. The effects will play out over timelines far longer than any human lives, but the processes are very real. Once it slides past, geological settling could cause slow subsidence. The Appalachians themselves may lessen in height over tens of millions of years without subsurface support. Tom Jernon calls the NAA a puzzle-turned-page of Earth's hidden dynamics. He notes, this thermal upwelling has long been a puzzling feature of North American geology. The new evidence aligns with a more recent continental breakup, one that reshaped Greenland and North America. This discovery reshapes how we view continental interiors, not dormant at all, but alive with slow, creative change. It hints at unseen structures beneath all continents that still influence surface geography. New York stands in the shadow of mountains built and maintained by forces rooted deep beneath the Earth's crust. These slow, hissing pulses of molten rock, ancient and enduring, are reminders that our planet is alive. It breathes, shifts, and molds the world in ways we can't see or feel. there's no need for immediate concern. But remember, Earth doesn't wait for us. The NAA is a silent architect shaping landscapes over epochs. Its presence shapes history beneath our feet. If this mystery of the deep gripped you, hit like, subscribe for more Hidden Earth Chronicles, and ring that bell so you hear every rattling echo from the crust below. Scientific investigations into the Earth's mantle are revealing more than just the mysterious, hot blob beneath New York. Researchers have uncovered multiple subterranean anomalies, unusually hot or compositionally distinct zones, scattered deep within the planet's interior. Some appear in regions where no tectonic activity is expected, adding another layer of geological intrigue. A notable finding comes from Swiss geophysicists at ETH Zurich and Caltech. They used advanced high-resolution models to map previously unseen regions in the lower mantle, including zones of colder or compositionally unique rock, challenging the idea of a well-mixed, slowly flowing Earth's interior. Together with other discoveries, these findings hint at what geologists call sunken worlds, ancient fragments of Earth's crust buried deep below and lodged in entirely unexpected locations. These silent, hidden layers underscore how much remains undiscovered beneath our feet. Mantle waves, the slow pulse beneath the Earth. At the heart of this mystery lies the intriguing concept of mantle waves, a chain reaction of thermal convection launched when continents rift apart. Imagine, when a continent starts to split, the Earth's mantle responds with upward surges of warm, buoyant rock. As this rock cools and becomes dense, it sinks, triggering a drip effect that travels inward beneath the continent like a ripple in slow motion. Scientists now believe the NAA is one such drip, formed when Greenland and North America separated around 80 million years ago, as confirmed by seismic data and modeling. This mantle wave is still slowly moving under the Earth, shaping the region's geological story. Surface impact, continents live and breathe. What does all this mean for the ground beneath us? These mantle waves, once seen as silent geologic whispers, can actually uplift continents by removing dense rock beneath them. This buoyancy helps preserve mountain ranges like the Appalachians, even as wind and rain try to level them. That means underneath the stoic visage of stability, there is movement, slow, potent, and unseen. So, is New York in danger? Not in our lifetimes, or even several million years. But this story reminds us, the Earth below us is alive. Slowly, persistently, it molds the crust with rhythms so gradual we hardly notice, until evidence like the hot blob jolts us into awe. If you're haunted by the knowledge that mountains might sink and continents shift millions of years from now, you're not alone. Subscribe, hit like, and join our next descent into Earth's secret heart, because not all mysteries roar, some whisper from deep below.